MX Phoenix Hexapod. Sit back, relax, and enjoy the journey with this impressive hexapod robot. Its creator reveals that the spider-like structure weighs a hefty 10.4 pounds, and what's truly remarkable is that the movement algorithm and many of its components were crafted by the author himself. For those interested, the creator has shared plenty of detailed photos on zentrusrobots.com, making it possible to replicate something similar at home. This is amazing. Please create a 6-foot-tall version that can reach 9.3 miles per hour, one viewer commented. Robotic dog. We're living in the 21st century, where engineers are testing flying cars, drones are delivering pizzas, and scientists in the US have trained AI to identify a patient's race from X-rays. So, when you hear the term robotic animals, you might imagine something like this. MIT Mini Cheetah. So far, the progress in this field has taken a bit of a different turn. On screen, you can see a project from MIT. Their robot cheetah may not win any beauty contests, but it can reach speeds of 25.1 miles per hour. While still slower than a real cheetah, the robot has an edge: it can self-learn. Plus, it's easy to repair. The assembly process is like putting together a Lego set, according to the designers, making it easier to carry out a variety of experiments. Harvard Arthrobots. Here's an alternative from Harvard. In the US, around 175 billion plastic straws are used and discarded each year, so it's refreshing to see that at least some of them are being put to use for scientific purposes. This spider-inspired invention is incredibly simple. Air is pumped into the modified straws, causing their flexible joints to straighten out. The engineers have crafted both individual legs and entire robots that resemble stick insects, spiders, and even water striders. The movement is controlled by Arduino microcontrollers, and the software development was quite complex. They had to design an entirely new algorithm to control the gait of the 8-legged robot. Kawasaki Bex. The robot cheetah might soon have some competition from a robot goat developed in Japan. Local engineers, under the Kawasaki Corporation, introduced this innovative robotic goat at the Robodex 2022 International Exhibition. During the showcase, they demonstrated various ways it can assist farmers. The robot is designed to carry up to 220 pounds and operates in 2 modes. Wheels are used for smooth surfaces, while legs are engaged on rough terrain. It can be controlled manually in both modes, but it also has the ability to move autonomously. Robot Rat Esturo. Chinese innovations are equally fascinating, such as these robotic rats. They're designed to assist in locating people beneath rubble, conducting inspections in hard-to-reach places, and performing other similar tasks. Weighing just 7.8 ounces, this version was developed after closely analyzing X-ray images of real rats. It has passed several tests, including transporting a load of up to 7 ounces along a slope of up to 20 degrees. The robot rat can right itself if it falls, bend its body, squat, climb obstacles, and crawl. The engineers are now looking to commercialize their creation, with plans to develop a version equipped with sensors for pipeline inspections. Titanoboa. Did you know that thousands of years ago, what is now Colombia was home to the Titanoboa, a massive 43-foot-long snake weighing over 2,200 pounds? Scientists only discovered its true size through the study of fossilized remains, as the Titanoboa went extinct long ago. However, in today's video, we've brought this ancient giant back to life, sort of. Engineers from Canada have recreated the Titanoboa as a robot, and they believe it's the largest of its kind in the world. The project began in 2011 and was completed in 2015. The 50-foot-long robot is powered by 8 Arduino Mega microcontrollers and motors capable of generating up to 25 horsepower, enabling it to move at speeds of up to 2.5 miles per hour. The robot's batteries last about 30 minutes, and the team is currently searching for a museum, gallery, or exhibition space to host the robot permanently. Snakeskin Robot. Snakes have also piqued the interest of scientists in the United States. This robot was developed at Harvard University, and what's particularly fascinating is its artificial skin, designed with scales resembling those of a real snake. The robot operates by inflating the system with air, which stretches the skin, allowing the scales to grip the surface and propel the robot forward. The engineers drew inspiration from the Japanese art of kirigami, which, unlike origami, involves cutting rather than folding. After experimenting with various designs, they chose trapezoidal cuts, which enhanced the robot's movement length. Their goal is to deploy this robot for various tasks, including potential use by rescue teams. RoboBee. For DIY enthusiasts, this unique robotic wasp offers a fun challenge. The $150 kit contains over 1,000 pieces and promises at least 4 hours of engaging assembly time. With a difficulty rating of 3 out of 5, it comes in 2 versions, a standard model and one featuring light and sound effects. Once assembled, the Wasp measures approximately 8 by 8 by 8 inches. Made primarily from iron and copper, the kit weighs about 2.2 pounds and includes tools like a screwdriver and pliers, as well as 2 options for wings and tail pieces to enhance the model. As the seller puts it, you'll enjoy the satisfaction of building it with your own hands. MIT RoboTuna. Why reinvent the wheel when Mother Nature has already perfected it? A prime example is this robotic fish, inspired by the Pacific bluefin tuna. In tests, the prototype successfully swam to a depth of about 40 feet for 40 minutes, smoothly navigating the currents while capturing images. The Robot Tuna project aims to develop compact robotic submarines for various tasks, such as detecting contaminants, mapping ocean floors, and more. Currently, engineers are facing challenges with battery life, as the power drains too quickly. To address this, they've decided to tackle the problem from a new perspective, focusing on improving the overall housing. The robot is a versatile experimental model, according to the engineers. StickyBot. This is considered the best invention of 2006 by Time magazine, a robot designed to climb vertical surfaces. Developed at Stanford, the engineers drew inspiration from geckos. These lizards' feet are truly remarkable, and it wasn't until the invention of the electron microscope that scientists could examine them in detail. They discovered that geckos' feet are covered with tiny bristles called setae, about 14,000 per square millimeter. This unique structure gives them an incredible grip, allowing them to hang from surfaces with just 1 foot. Stanford's team aimed to replicate this with a version of the bristles, which are 5 times thinner than human hair. One major advantage of this design is its low energy usage, unlike suction cups or sticky materials. The robot is already capable of moving on wood, painted metal, and even glass. In the future, it could be a game changer for builders, rescue teams, and researchers worldwide. Flying Goose. Let's head to Germany to check out this robotic goose. From a distance, it's nearly indistinguishable from a real one, sparking concerns in the comments that it might one day be mistaken for a target. Some have even suggested using it as a kamikaze goose for military operations. The current version can stay airborne for around 15 to 20 minutes and comes in different models with wingspans of 64 and 73 inches. Its head is crafted from basswood, beautifully painted, and paired with the robotic body, giving this handmade creation a distinct and recognizable appearance. Festo Aquapenguin. In Hanover, local engineers developed a robot penguin weighing 21.2 pounds. It features an independent navigation system and can swim on its own or in groups. Powered by an electric motor and 15 amp-hour batteries, the robot can reach speeds of up to 3.1 miles per hour and stay submerged for up to 7 hours. Its flexible torso, made possible by fin ray technology inspired by fish fins, gives it remarkable agility. Engineers point out that penguins, known for thriving in cold Antarctic waters, have a design that minimizes energy use while swimming. With various internal modifications, these robot penguins could tackle even the toughest challenges. SquidBot. A fresh perspective on squids, no, not the TV show, comes from a group of scientists who were inspired by these creatures to create a robot designed to explore the underwater world. They've incorporated the key features squids use for high-speed swimming into the design. However, there's still a long way to go in the testing phase. The current model reaches a speed of about 0.62 miles per hour, while the Humboldt squid can swim at speeds of up to 15 miles per hour.